Hello everyone. Today we're going to explore something fascinating and fundamental to the world of computer science: algorithms. Now, I know what you might be thinking, algorithms? That sounds complicated. But trust me, it's not as daunting as it sounds. In fact, you use algorithms every day without even realising it. Think about the last time you baked a cake. You followed a recipe, right? That recipe is actually a perfect example of an algorithm. It's a set of instructions designed to perform a specific task, in this case, baking a delicious cake. Every step you followed, from mixing the ingredients to setting the oven temperature, is part of this algorithm. In computer science, algorithms are like these recipes. They help computers solve problems and carry out tasks efficiently. Whether it's sorting your emails, finding the fastest route on a map, or recommending a movie on Netflix, algorithms are at work behind the scenes. So what exactly makes a good algorithm? Let's break it down. First of all, clarity. An algorithm must be clear and easy to understand. Number two, a definite start and end. It should have a clear beginning and an absolute end. Number three, finite steps. The solution should be reached in finite number of steps. Precision. Each step must be precise and executable. Now, algorithms are all around us, helping solve both simple and complex tasks. They are the unsung heroes of our digital world. So how do we decide upon algorithms? Let's go through some steps. First of all, we have to identify the problem. Clearly define what needs to be solved. Then we break down the task. We list every step needed to solve the problem. No step should be too big or unclear. We then order the steps. We arrange the steps in a sequence that makes sense. Sometimes steps might need to be repeated, and that's okay. And then we test the algorithm. We follow the steps to see if they lead to the correct solution. If not, we might revise some of the steps. Let's say we want to write an algorithm for making a cup of tea. Here's how we could break it down. Number one, boil water. Number two, place a tea bag in a cup. Then pour boiling water into the cup, let it sit for a few minutes. Remove the tea bag, add milk or sugar if desired, stir and enjoy. And there we have it, an algorithm for making tea. But algorithms aren't just for everyday tasks. In the world of programming, we can use tools like Scratch to visually create algorithms to control sprites and create games or stories. Each block in Scratch represents a step in the algorithm, making it a fun and interactive way to learn. In summary, algorithms are like recipes for solving problems. We've seen how to write them and how important it is for the steps to be clear and in the right order. By practicing with real-life examples and programming tools like Scratch, we can get better at thinking like computer scientists. So next time you follow a recipe or solve a problem step by step, remember you're already thinking like a computer scientist. Embrace the power of algorithms and see how they can make your life easier and more efficient.